So hello and welcome. I have another video here. I try to keep my voice down, my voice low. What I would like to do, I have the gain set very high, so I'm going to try to whisper while we work through these problems. So the plan is going to be, we're going to pick up another problem, C++ problem, and let's get right into it. So practice coding interview related questions. So design hit counter. Okay, here we go. Let's see how we do. Design a hit counter which counts the number of hits received in the past 5 minutes. Each function accepts a timestamp parameter in seconds granularity, and you may assume that calls are being made to the system in chronological order, i.e. the timestamp is monotonically increasing. Excuse me. You may assume that the earliest timestamp is starts at 1. It is possible that several hits arrive roughly at the same time. Counter new hit counter. Hit at timestamp 1, hit at timestamp 2, hit at timestamp 3. Get hits at timestamp 4 should return 3. Oh, interesting, okay. Hit at 300. Get hits at timestamp 300 should return 4. 301 should return 3. Why? What is this? How does this work? What is this? I don't understand. 1, 2, 3 gives you 3 hits, and you get the hits at 4. You get 3 of them. Hit again, 300. Turn hits at 300, you get 4. But if you go 301, you get 3? A lot of likes. I don't understand what, how, what? Hold on. What is going on? Why do you get 3 at 301? Oh, I see. 5 minutes. Got it. Got it. Oh. Interesting. The number of hits per second could be very large. These are design scale. That's a good question. Alright, let's think about this. Well, if it's only the seconds timestamp, then you could use an unordered map and map the number of hits. In fact, you could do better than that. You can do no. Well, let me think here. I want to say something like you could have an array of values from 0 to 300, and or maybe 1 to 299. I guess you can't have a timestamp at 0, can you? Earliest timestamp is at 1. Yeah, okay, so we'll do 0 to 299 and just map timestamps back, subtract 1, and basically as timestamps come in, you would update your array. I don't know if that makes sense. The calls would be made in chronological order, meaning you won't have like hits for 10,000 and hits at 200. So you can do this in basically have an array that you loop through. So when you want the total, you can actually go even faster than that. You can do an array and take the sum over the array, and you can actually, if you wanted to do it in logarithmic time, so it's constant time to update the array. You could do it in logarithmic time to update it on logarithmic time to get the answer you're looking for using a, what do they call that? An interval tree. Using is that right? An interval tree? Yeah. Using an interval tree. Which also, the interval tree, you can organize that in an array as well. Yeah, that's kind of an interesting way to do it. Maybe I should do that. Considering doing that, implementing this as an interval tree rather than a simple array. A simple array works fine too, because each time because it's a sort of a constant, it's relatively small constant, the size of the array, then calculating the hits for that array should be relatively efficient anyway. So it really shouldn't be too bad overall. You don't necessarily need to go into logarithmic complexity. I don't actually know if you can do this with just an array. I take that back. I think you can, but so how would it work? Excuse me. I'm thinking you want to read the array the past 5 minutes. For the first 5 minutes, it's just an array, and you just write right into the array, increment the number of hits. Once it gets to 6 minutes, now you're overwriting. And you're actually going to go from the back. There's some point, let's say 6 minutes, or let's say 600 seconds rather, which is a little more than 6 minutes, or 5 minutes is 300, let's say 400, right? So it's a little less than 7 minutes. We say, so we have 100, we wrote 100 into the array. Now the tricky thing is actually better would be to use 2 arrays. So use double the size of the array, and you clear the previous array once you're done with it. No, the tricky thing is like if you go like 700 seconds out instead of 300, you don't update your pointer correctly, let's say. Yeah, we want to basically keep the array in touch. Excuse me. Just thinking about this. You probably do want to keep a counter then to see where you wrote your previous hit in. Oh boy. I ate a bunch of food and it suddenly hit me. I'm getting like very tired. Let me lay down for a minute or two and just kind of ponder this. I think tricky. So I actually don't think. Take it back. No, I do think you could still do this with an interval tree, but you've got to be kind of clever about how you implement this array. So what you would want to do is add the what you would want to do. Excuse me. What you would want to do so clearly for the first 5 minutes you could just add everything in the array up to the point that you're looking for. Once you get to, let's say, somewhere between 5 and 10 minutes, now the issue is you want, there's a certain point in the array that you're going to stop at. And the issue that you run into is that the values in the array excuse me. There's a section of the array that you want to sum. However, the values of that section can and should be 0 for a chunk of it. Well, you don't even add it, really. Well, that's the thing. It depends. If there are hits in there, I guess you could set a Boolean or something. If there are hits in there, then when you set the hit, you set everything before it to 0. If there are no hits, then you just assume it's 0. Don't even add it. Leave the data in there. And then the thing is, what if you end up one more iteration away? In other words, these are the rules that if you're between 5 and 10 minutes, what you can do. But what about when you go to 15 minutes? So less than 5 minutes, you've got this array to work with. And then between 5 and 10 minutes, you want part of the array, and you're also going to write into part of the array. So you've got part of the array, and you're going to write into part of the array. Yeah. The first 5 minutes, and for the next 5 minutes, right? Yeah, and I guess you want to keep a Boolean. Not just a Boolean, but what you kind of want to do is have basically divide the timestamp by, the remainder is where you're going to write in, but you can divide the timestamp by 5 minutes by the size of the array to get an idea of how many iterations out you are already, sort of how far you've already gone. And what would happen is, the tricky thing is you want to know where your written, what the last write was. Let me think about this here. Let me think about this. This is a good question. It's an interesting question. I'm grateful for the, I'm starting to see why it has 1,000 upvotes. It's an interesting question. Yeah, basically, what you can do is hold on to a number once you write to the array, and you can say, take that modulo 300, and that's where it should be written. And you can also divide that by 300. And I guess the most recent one, you keep updating this number, divide by 300 to give you the sort of how many iterations outwards you are. And what you'd want to do is once you've there's this tricky thing where you know what the maximum iteration is, and then you would assume the data in front ahead of it, so like modulo 300 might give you 100. Everything from 101 to 299 would be one less, would be part of the previous 5 minutes, I guess, or not the previous 5 minutes, but it would be part of, I guess it would be part of the tail end, the last set of data. And so if you're looking to get a certain amount, or you're looking to write, so when you write a certain amount, if that exceeds sort of the previously written by more than one, I guess, or enough to go into the next iteration, then all of the data above also would get rewritten, if that makes sense. And I'm sorry, how I'm describing where the data is really confusing too, because I'm looking at an array, but I'm looking at the array moving downwards, so you have sort of like 0, 1, 2, 3 would be, if you wrote it just straight down in a line, 0, 1, 2, 3, and I'm thinking of those as the array indices. So forgive me, I'm describing it as writing things above and below, and it's like there's no reference point to even have any idea what I'm describing. So sorry about that, but it's basically just visualizing an array that we're kind of using as a revolving door for information, something like that. And at some point where the information is there's sort of like a set of 5 minutes, and then there's some like chunk of time after 5 minutes where that's going to get written into the array, and it's going to exactly take up the part of the array that we've sort of passed by already. That our 5-minute window, it's out of the 5-minute window. But then you have issues of like, well, what if you write or read things that are completely out of the window or windows? So something that's only I guess it depends on the previous timestamp, if it's, and depending on how many, or you can just compare a division of the timestamp with an integer division with the previous value, or not even the previous value, but you can keep track of like what this interval is supposed to represent right now, and it could be the first 5 minutes, or it could be part of the first 5 minutes and part of the next 5 minutes, from 5 to 10. So it'd be sort of partially 2 and partially 1, and then it'll then eventually go to partially 2 and partially 3, and then partially 3 and partially 4. Right? It'll just kind of keep moving. But the reason why that's significant is that if you get a read that's at 5, and you're looking at partially 3 and partially 4, then basically you just dumped all the data from that point. Or you would really only read the portion of 4, I guess. Yeah. And all of the 3 data would get erased. You could erase it at that point. Right, because obviously you still have parts of 4 that you would read when you're reading, 5, so things from 5. So you wouldn't delete the 4 data, but you would delete the 3 data. And that's kind of how it would go, I think. If your write is in 5, then also that would overwrite everything in 3 as well as in part of 4, or yeah, it would erase everything in 3 with certainty, and then whether or not you would write 4 or erase 4 is another question. That's something to think about too. How does this thing work in practice? Yeah, it's kind of an unusual application manipulation of arrays. So I've got to really think about it. Give me a minute or two to just kind of close my eyes. I'm suddenly really tired. this, man. I like doze off for a minute or two, and then I freaking drool. Freaking drool on my face, man. I don't know what it is. I must be really tired or something. Just like clock out. Nope. Oh. Oh. I make that noise. I've noticed other people start making that noise. Oh. Up. Oh. Oh man, I'm ready to go to bed. Ready to take a nap, but I think I got it. I think I've got something of an idea. Sort of exactly what I was just describing with when you write and read, you can update in the array with regard to the previous read and write. And you basically erase. With writes, you would erase everything below up to the last write, you know, the modular, whatever it was, the last write. And if you read, you would erase everything up to the previous write. Right, wherever you're reading from, also erase everything. And basically, you could take the entire array from there. There is one issue, though, as I said, with the reads and the writes if you are too far ahead. In other words, if you end up past the that's the thing. What if you have elements in the array from 3, from things from 10 to 15, and then elements from 15 to 20, which is 4, and then now you're tinkering with elements from 5, which is, so what do we have? It's 0 to 5, 5 to 10, 10 to 15, 15 to 20, and then 20 to 25. So 15 to 25, this 10-minute section. Well, you would erase from the previous write, which is in the section 4, we'll say. Basically, you erase everything from 4 all the way up, right, which is all 3, if you're dealing with 5. And then wherever you write the 5 in, that'll actually overwrite sections of 4 as well, if not all of it. Could end up overwriting the entire array. Yeah, that's a tricky thing. And obviously, if you're reading or writing from 6, it would just clear everything. You just clear the whole array. Huh. Oh man. This is tricky. Also I don't want it to be too expensive either. Think about it. You can maybe think of it this way. Think of it like a rotating memory chunk, and when you move forward into the future, you want to allocate space, and so you take the difference between the previously written or previously read piece, and then you want to allocate it, basically write zeros into the new section, and that's kind of independent of either operation. Now, the problem with that, though, is that difference between sort of the new spot to write and the old spot that you wrote to is, yeah, it kind of matters where and how that happens. Like, so if the old spot was at 100 and the new spot is at 200, and they're both, modulo 300 the same, divide by 300, they give you the same divide, same, I guess, dividend. You get the same dividend. I want to say, I don't know if dividend is the right word. If you get the same dividend, then it's rather simple. But if you have a different dividend, then what do you do? if the difference between the new write and the previous write is greater than or equal to n, then you just erase the entire array. Allocate more space. If it's less than n, that's when it's interesting. If it's less than n, then you can sort of allocate backwards. I think that's the way to understand it. And then if it's a read, then you would basically take the sum of the whole array after you sort of do this quote-unquote allocation. If it's a write, then you would add 1 after that allocation occurs. And if you write to the same spot that you were, if you wrote to if the spot is the same, if the previous timestamp was the same as the current timestamp, then you don't need to do any of that quote-unquote allocating. You just increment right there. But you would allocate on the spot for the timestamp too. As well, I set that to 0 as well. I think that's the way to do it. I think it's relatively simple logic. So I'll write this allocation routine that's going to take a previous value and a current value for timestamps, and you're going to take the difference between the two. Then you're going to say, okay, basically write zeros from the larger one to the smaller one modulo n. If the difference is right, the difference is between 0 and n, that's what you'll do. If the difference is greater than n, then you're just going to erase everything. You'll clear the whole array. And yeah, it's pretty simple. That's the allocation routine. Called allocation routine. And then the writing and the reading, when you read, you're going to allocate and then basically take the whole array. Allocate up to the new read point, and then just take the sum of the entire array for the hits. And then the other routine, the write, you're going to allocate unless the previous is equal to the current, right? Then the timestamp you're looking at. So you'd want to save the previous value if they are, right? You save them for both routines. If they're equal, the previous and the current, then you just increment that spot. If they're not equal, though, then you want to allocate up to the current. And as I said, it's sort of some circular or modular arithmetic sort of allocation routine. It depends on the difference between the current and the previous. So I'll write that sort of private subroutine. And yeah, and that actually should do it. That would give you a solution. And then that solution could be rewritten in using an interval tree rather than an array. And you'd actually implement the interval tree into an array. And the reason you would do that is that your allocation routine would be a lot faster, as well as the summation routine. It would be logarithmic time logarithmic with respect to the total array size, rather than logarithmic of n rather than O of n logarithmic of whatever the constant is, 300 we'll call it, rather than 300 every time. So the allocations would become logarithmic instead of constant. I mean linear with respect to it's a constant anyway, but this would scale a lot better, I think. It would scale a lot better for the situations where there's a large number of hits in one time, or yeah, short periods of time. Actually, this works really nicely if there's a lot of numbers, a lot of hits at one period of time. What it doesn't work particularly well for is if there are a lot of calls to get hits in a short period of time, which it really couldn't be, right? Because you really would have just one call every second, right? So really pretty interesting. You really don't need to use an interval tree. It would make things more efficient, but it's kind of unnecessary. Pretty interesting question. I think I have the solution. So, as I said, we'll give that a shot. The logic is going to go as follows. You have an allocation routine. If previous is not equal to current, and previous and current, previous is going to be the previous timestamp that we write to, and also the previous is going to be the last timestamp that we read from as well. Now here's the thing. You can read, no. You can read wherever you want, right? Oh no. Oh, shoot. I made a mistake, huh? Uh-oh. Yeah. Oh, no. That whole thing doesn't make any sense. Because you can use get hits on... Oh, no, man. Yeah, you can use get hits on... Gotta be kidding me. Whatever you want. Oh, no. Shoot. Alright, let me think about this some more. Oh, yeah. Shoot. Alright, let me think about it some more. No, wait a second. Maybe I'm crazy. Hold on. Are the reads when you write the get hits, are those in chronological order? Because actually these are excuse me, very different questions, very different situations. The calls are made in order. Okay, never mind. No, it's fine. I had the right idea. Okay, let's try to implement this then. Let's try to give it a shot. Yeah, I'm like ready to fall asleep, but let's give it a shot. So I think I know what to do. We're gonna have a so this allocation routine. So int previous, and we're gonna say array size. And in this case, the array size is 300. It's really this. I don't know if you can have constants and I don't know if you can have like a static constant for the class. I don't know. I haven't really done that very much. I think I tried doing that once, but like a static const expression. I don't know, we could try it. I don't know if that'll actually work. Hold on, you know what, let's just, what does this do? Does this compile? Oh, it does. Oh, no kidding. In that case, we don't even need this. Okay, so make it unsigned, why not? So in previous we don't actually need, I'm thinking about using a vector. Is that right? Doesn't seem right either. Oh, you can actually do oh, interesting. Okay. Yeah, that's what I want to do. Okay. And we're going to have an allocation routine. And we're going to take really don't need that, do we? By the way, previous could be just 0. Oh. All these timestamps, you kind of want to subtract 1 when you're working with the array as well. It's kind of one minor detail. Yeah, so the previous is 0. And we say int diff is equal to t minus previous. If diff is greater than or equal to n, then we're going to standard fill array.begin, array.end with 0. Otherwise, we're going to take this difference, right? So we're going to go from its previous modulo n and t modulo n, and we're going to say from t to previous, right? So we're going to say for int x equals t modulo n, x is not equal to, now the thing is, yeah, x could be all over the place, previous. So let's do int target minus x, and right, keep that modulo n, and you're going to say array of x equals 0. And then also array of target equals 0, right? And set previous is already 0, array is 0. Excuse me. We don't actually need to put anything in here at the end of the hit counter. No, we're fine. Everything's fine. So we're gonna say if timestamp equals previous, and do some things. Now we're going to say array of previous plus plus. Otherwise, timestamp's got to be larger than previous. We're going to allocate space up the timestamp. And then we're going to say array of timestamp plus plus. So that'll get set to 0. And if it's equal, we just keep incrementing. So if multiple hits come in at the same time, we just keep incrementing. And now do we erase this previous value? I don't think that we do, actually. I actually don't think we do. I think that's incorrect. So now, when we get hits, we do a similar thing. Say if the timestamp is previous, right, then we're going to want to just read the entire array. Sum, right? Or accumulate, something like that. First, last, initial. Yeah. And return that. Otherwise, allocate this space up to this new timestamp. And then set this previous to the new timestamp. So you don't need to allocate space again. I think that's it actually. If you get the hits, allocate that space. I think you return this again. Does that work? No. It's close though. Oh. Actually. That's the only problem, I think. Just have to shift the timestamp by 1. I think the logic's the same. No, wrong. Really? No. Come on, really? Oh, if they're equal, if previous and target are equal. If it goes negative. Oh no. You just throw this in here. What is going on? I don't have any loop. This is the only loop in here. What did I do, man? This is definitely the issue, right? That somehow we end up looping. Yeah, man, I always get mixed up when dealing with arrays like that, where things get kind of messed up. So, we're mapping 1 to 300 to 0 to 299. So it gets a little confusing. That should be fine. We just have to do one extra step here. We'll modify the timestamp. But for whatever reason, it doesn't seem to work properly. So if we walk through this one increment by one, 2, say allocate space between, I gotta sneeze. Between 2, which is 1, and 0. So the previous is 0. So, yeah. So the timestamp 2, allocate space with 2, which is just 1. So 1 and 0. Previous is, what's target and previous and X and all this, what is all of this? So previous is 0, T is 1, diff is 1, target is 0, X is 1, X equals, right? So X gets set to 0 here. And then this gets set to 1. Can actually one, 2, 3, 4, right? 1, 2, 3, 4. Excuse me. Now, this get hits at 4. 1, 2, 3 seems to work fine. When we get hits. Oh, that's why. That's my mistake. Still, this loop should never do what it's doing. Well, this doesn't need to change. What is? How is this loop? Previous is smaller than T. And how come, like, this should always just exit, right? Like, why does this loop go on infinitely? What happened here? One, 2, 3, and then 299 all the way down to 4, 0, 195 all the way down, 0, 195 all the way down, 0. What is going on? Why is this happening? What the heck is going on here, man? Why is this just looping over and over again between 0 and... Is that because I used an unsigned integer that it's converting these values to these unsigned integers? No, man, come on. I want to say, I guess it's got to be greater than 0. No, it could be equal to 0. If you make these... I've done this before where my loops get funky because I just randomly throw in an unsigned integer and then I can't get my loops to stop. Brother, you gotta be kidding me. Oh, it's correct now too. Oh, wow. Yep. Yeah. And it's funniest thing is it's correct now. Somehow now it's correct. Now that, I don't understand. This shouldn't run into this problem. Let's do this at each step. Let's see what this thing looks like. This shouldn't be necessary, this piece here. I don't think it is, actually, now that I think about it. Oh. Yeah. I guess so. I guess it is necessary. I don't understand. I don't know what happened here. This shouldn't be necessary, this piece. It's not possible not to hit the target. The only way it's possible not to hit the target is if T... Hold on, when does this... Hold on. Okay, we have 1, 2, 3, 4. 4 iterations of things, right? 1, 2, 3. Wouldn't there should be 4, 5, 6, 7? Why don't I have... Oh, because these return. Oh, that's why. Yeah, gotcha. Yeah, man, this is the kind of thing that just, I don't know why, like, I struggle so much with certain, like, algorithms I'm not familiar with, things that are, like, sort of custom, totally custom things. So 1, 2, 3, 4, 5, 6, 7, right? That's what 1, 2, 3, 4, 5, 6, 7, yeah, that's what we expect. Alright. Now if we get rid of this, where does this stop? 1, 2, 3, 4, 5, 6, 7. Really? One more time. 1, 2, 3, 4, 5, 6, 7. For some reason, 7 gives us an issue. Prints everything. Underflows. I think I know why. Because if you underflow, I don't know, actually. The reason why I'm thinking we need to watch out for the underflow here is because the way modular arithmetic works for we can maybe do this. No. No, it's not correct. Yeah, I think we do need to have... No, that's wrong. No. I think I know what's going on with the problem is. It's got to be something like this. X is t, and x modulo n is not equal to the target. And then x minus minus over here. And x modulo n. Yeah, something like this. Yeah. And that you should not have problems. It's a little confusing why, but the reason why you've got to do it this way is x being set to something modulo n means that it's going to underflow. Modulo n, when dealing with, not that it's going to underflow, but when dealing with computations, like C++, for instance, it actually doesn't, it's the remainder of a division. It's not actually the true mathematical modulo. So if you took like -5 modulo 10, that's, I think, 4, right? If you, or 5, actually, no, yeah, it's 5. So -5 modulo 10 is 5, whereas -5 modulo remainder 10 is, I want to say 0, or no, I want to say it's still -5, something like that. Basically, negative numbers when you take the remainder when you're dealing with computation usually isn't defined the same way that mathematical modulos are defined. So we've got to be somewhat careful here not to underflow. Like, in other words, we're actually supposed to underflow a certain amount and start looping back on the other side. However, we don't do that because of Yeah, we don't do that because of the loop that I had won't do that properly. It won't loop back because basically we're not starting off. It won't loop back because it'll just go ahead and start going to negative numbers at some point, and then you have to actually add n to it. You could do something like the following, which would be, no, well, this is sufficient. Just perform the division each time. This will loop back properly. Yeah, this should be fine. You can maybe speed this up a little bit by throwing in a division in here, but this should be okay. Should be okay. So anyway, yeah, so that seems to be correct so far. Let me get rid of all of this stuff. Maybe I can optimize a little bit. So there are some test cases we want to run through. There's quite a few. All right. Things we want to test. We want something that's empty. See what we get. Right. Okay, that's fine. We want something with just one hit. See what we get. Let's do one hit and one check. And we want to do one check. These are kind of like the really simple cases, I guess. Sort of like sanity checks. Excuse me. And now we want to check if we start kind of just adding a bunch of hits after 301, so 302 a few times. So we want hit, 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 get hits, hit, get hits, get hits. Right? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So we want 1, 2, 3, 4 hits and a get hits. Okay. Nice. All right, that's good. We tested that. The next 301 is outside this bound. Perfect. Okay, that's one of the things I wanted to test, certainly. when did that happen? And why did that happen? Oh. It's supposed to be modulo n here. And previous also is modulo n. Of course. Seems like a minor thing, but that's important. It matters. It's good that we tested it. Yeah, this is all about like testing the implementation, that it actually follows what you think it does. It's not really testing the idea as much as the implementation. Although the idea could be wrong too, but usually these kinds of tests are to make sure that implementation actually does what you think it does. Does what you want it to do. I have to do 600 as a hit. And you do 601 for get hits. Right? Ready for that? Okay, interesting. How about 603? Oops. By the way, saving all of these tests is basically for what you would call regression testing, where you would, when you make a change, you run all your regression tests to make sure those will still pass. How about this 603 to 602 for your get hits? So what does that give us? Oh, there we go, still correct. How about 900? Or 904? For your get hits over here. Zero, as expected. And what about, let's do a hit at 9, so let's hit a 9 at 905. And then another hit at, let's do 1,000. And another hit at, we're going to do, that would be like at spot 100, right? I want to go to 50. So it's like 1250. No. 900. Yeah, 1150. Let's do 3 more hits and a get hits. Hit, and a get hits. Like, I don't have a proof that this is correct, It's the thing I'm struggling with. I have an idea of why it's correct, but I don't have a proof. I kind of need a proof. I think it's correct. Let's do like 1,001. And get hits there, so, oops, no. There's like such a good chance that this is not correct, my program, I really don't know. Like I said, I need like a proof. spent so much time on this. Alright, I think we're gonna go for it. Man, there's so many things that could go wrong here. I don't even know. I don't know. Well, let's go for it. Oh, hey, we did it. And we're 100%. We're fast as can be. Alright. Let's see. Alright, sweet. So, alright. So maybe I didn't need to be so... Hey, well, nice to see you on here instead of on Twitch. Time to stay and watch, but hope live streaming well. God bless, brother. Yeah, hey, thanks. I appreciate it. I appreciate you coming by and saying hello. Is that LCN? Welcome. Hey, man. Yeah. Yeah, absolutely. Thank you. Thank you. Yeah, I moved off of Twitch. I don't know when I'm going back. But I'm still streaming. Still out here. And you have to forgive me. I don't recognize your username. If you had a different username on Twitch, I don't recognize it here, but hey. Yeah, absolutely. Good to see you. God bless. God bless you too. Absolutely. Yeah, life is treating me very well. I'm an extremely lucky man. I have my ups and downs, you know, as everyone does, but today was one of those days where I had a big down and a big up. And I'm really lucky. I'm a really lucky guy. That's all I can say. Yeah, thanks for coming by and saying hello. I appreciate that. Thank you. Thank you. Looks like we got it. What I want to do is I want to modify this code so it's a little bit easier to understand. So the thing is, this accumulation, you do want this to happen after the allocation of space. You can have something like this and say red is equal to that, allocate space, and then set red equal to that, and then otherwise previous equals t is going to happen no matter what you do, right? It's going to happen here, it doesn't really matter, it happens here and it happens here. Actually, there's only two if-else's, right? So really, and these happen in both cases. These happen in all of these both cases. So you don't really need that there. So you just need if it's not equal to allocate space. And in fact, you don't need ret anymore. And in fact, you can say, you don't really need to modify this either if it's not here. Oops. Does this work? Let's see. Let's try these. And I should say also, I hope you're doing well too. I don't know if I said that. I'm just thinking my response, the way that I responded. With a video, I have the opportunity to add that. In person, if the person already walked away, you can't like, oh, by the way, here's all the things I wanted to say that I forgot to say. I'll never get to say. There we go. That's a little bit better. Let's see, is it still correct? It is. Somehow less efficient, though. That's interesting. And there we go. This one, I think I did this correctly. Right, slightly different if you're in each case. I think this is right. Actually, what's interesting is previous is equal to t. So actually, no, you can change this one too. This is actually the same no matter in both cases. And then you can change this to not equals. So you can actually update this logic too, if you wanted to. So it's simpler. There you go. One more time. I just get lucky all those times? Man, I got lucky twice. Oh, really? There we go. Yeah, look at that. Isn't that simple? Isn't that just beautifully clean logic? And how about this logic? This one, I think, is kind of is what it is. Yeah. This one, I don't think we have too much of a choice. I like this, man. I like this question. I like this implementation. It's pretty clean, pretty simple. It took me a while to get there, though. I had to really sit and think about it. I'm gonna end the stream here for this problem, so it'll be kind of contained, self-contained. And yeah, I did all these tests, man. Because I got beat up for the last question, man, and I was like, I can't be getting these wrong. I gotta do more tests. So yeah, thank you all for watching. I will talk to you soon. Have a good rest of your day. Oh, now here's a moment of truth, though. You ready for this? You ready for this? How about this? No, this won't work. Oh, it does. Wait, what? No. Does it still work? It does. Huh. You wouldn't? Okay. Huh. I guess the issue wasn't really that there's actually two issues. I think it was unsigned and this value was supposed to drop under. It's actually supposed to go below, not necessarily negative, but below 0 mod n, right? Which then it goes to n-1 mod n. Interesting. Yeah, you gotta watch that. Converting your values to unsigned integers, or well, actually, really, kind of wasn't the problem. Sort of was, sort of wasn't. I don't know. But yeah, it's a very. I would actually just not. I actually just wouldn't make it unsigned if you don't have to. Just let it be. Just let it be. All right. Pretty good. So yeah, I'll end the stream there on that one. This was good. This was good. So thanks again. Talk to you soon. And let me end. I'll end here, and then do another problem. And I was gonna take a few minutes, but I'm kind of like ready to go, man. I'm kind of ready to like take on the next problem. So let's go. Let's do it.